Hello everyone, welcome to my channel. Today we are going to discuss on a problem which was asked in IIT-JAM 2017. It's a very important problem and a very important rearrangement actually. The problem is based on Favorskii rearrangement and followed by the ring closure. Okay, so the problem is in the following reaction the major product T is. Now you have to find the structure of T. You have given a structure like this, and there is a base, that is sodium methoxide, then given H2A plus and reflux, and in the third step we have given polyphosphoric acid, that is called in short PPA. Okay, we all know that thing. Now before starting to solve this question, we have to know what is Favorskii reaction, or what is Favorskii rearrangement, and how to identify it. So you have to know what type of compound undergoes in this rearrangement reaction. At first the compound should have the following features which I am writing here. The compound, okay, first the name reaction is Favorskii rearrangement. Now what type of compound undergoes in this type of rearrangement? Okay, first of all, the compound should have alpha haloketone. Okay, so what is alpha haloketone? That is now if this is acetone. Okay, so the position there is a methyl group and there is a methyl group. This is a functional group, and with the position which is adjacent to the functional group is called alpha. That is, this position is called alpha. And if there is a substitution like any halogen, I am writing here is only X is equal to any halogen, then this type of compound is called alpha haloketone. Now there is one more thing, that is the compound should contain an acidic hydrogen. Okay, so second point is compound should have acidic hydrogen. Okay, now and the reagent that is you have given in the Favorskii rearrangement, that is a base. Base like reagent is base. Base like alkoxide or hydroxide. Now what is alkoxide? Alkoxide means this one, sodium methoxide, that is, this is alkoxide, and the hydroxide like NaOH. Okay, now the reagent, now see here the question, in this question, the given question, the reagent is sodium methoxide, that is a type of alkoxide. Okay, now there is one more important concept regarding to this Favorskii rearrangement, that is the Favorskii rearrangement is very much regioselective as well as stereoselective. Okay, so this rearrangement has two different type of aspects, that is number one is regioselective, and number 2 point, that is also it is a stereoselective also. Stereoselective. Okay, now I will discuss these two cases, it is regioselective and stereoselective, when I am discussing the whole mechanism of this rearrangement. Okay, now let's see, there is a how to use and why this type of rearrangement is used. The rearrangement is used in various cases. I am taking as example, like if you have given a 6-membered ring, you have to convert it 6-membered to 5-membered, then this type of rearrangement used on these cases. Now there is a formation, so I am writing here that if you have given a compound that is 6-membered ring, and you have to convert 6 membered to 5 membered. In this case 6 membered to 5 membered convert, then this type of Favorskii rearrangement is used. Okay, now there is a different type of Favorskii rearrangement possible, that is only Favorskii rearrangement or quasi Favorskii rearrangement or homo Favorskii rearrangement. So there is different type of Favorskii rearrangements are there. Now we will discuss this type of various type of Favorskii rearrangement in another video. In short, I am discussing the quasi Favorskii. Actually, what is quasi Favorskii? Okay, now I will discuss on later. Now I am discussing the mechanism and how the reaction will proceed. Okay, so let's have a look of the mechanism. Okay, let's do the question. The question also follows this mechanism. Okay, you can easily understood that. Okay, now they have given this compound. I am writing this compound here. Okay, I am listing on one more important concept regarding this Favorskii rearrangement, that is there is a formation of intermediate which is formed during this reaction, that is a 3-membered cyclopropane type intermediate. I am writing this concept here, that is 3-membered ring, or you can call it cyclopropane type, that is intermediate. This is the intermediate. Okay, now here is a question which is given in IIT-JAM 2017. This is your substrate and you have given a base and sodium, like sodium methoxide. Okay, now you have to find the acidic hydrogen. Now there is a acidic hydrogen, sorry, this is not Me, this is Br, bromine. Okay, so methoxide, there is a acidic proton here. Okay, so this methoxide, what it can do, it can abstract the proton from this side, and this is the acidic proton as well, and there is a formation of this Br. Now I already mentioned that there is formation of 3-membered ring, then how it is formed. Now this is formed by this way. Okay, now after that there is a formation of methyl and this one. Now see, this is your 3-membered cyclic transistor state or 3-membered ring that is formed during this reaction. So this part is called your 3-membered cyclopropane type ring intermediate. Okay, now after that you have given in this reaction condition you have given the water, and if the water in this for this question, the water is used as a nucleophile in the system, but in different cases also other nucleophiles also used, like OMe or anything else. Now here is in this question, for this question you have given water. Okay, so in presence of water by H3O plus, I am writing the H3O plus in this way. There is a H plus plus water. Yes, is it right? Yes, it is right. And oxygen has a lone pair of electron. It can abstract the proton from this side, and after that the formation of this compound. Now then you have a free water and it's a lone pair of electron, and it can attack, and it will attack on the this carbonyl atom, this carbonyl group, attack on this carbonyl, and these bonds go here. Okay, now see, okay, there is a Me, and here is your OH, and this is also your OH. Okay. Now there is opening of this 3-membered base, because the 3-membered ring is not stable. It's a very strange system, so it tries to open up. And how to open? And these bonds will go up. Now there is a very much important concept that I'm already mentioned here, that is regioselective. The Favorskii rearrangement is regioselective as well as stereoselective. And now here the regioselective concept arises. Now if the bond backs here, now there is a possibility of two types of opening. If there is a possibility of these bonds will break, or these bonds will break. Now you have to check if the bond will break either this side or this side, there is a formation of negative charge, and you have to check which negative charge is much more stable, and then this side of opening will takes place. This side of opening will takes place. Now see here, I am adding these two possibilities, here A and here B. And if this opens like this here, and there is a bond O, and here is your OH, there is a pathway A, and here there is a pathway B, that is this. Here is your negative charge. Now see, here is a 1 degree negative charge, that is 1 degree carbon ion. Sorry, this is negative charge, 1 degree carbon ion, and here there is a benzylic carbon ion, which is more stable compared to this one. So here is the concept of regioselective arises, that this region at this position the negative charge is much more stable. So in this, so here the negative charge is much more stable, and this side of ring opening will take place. Okay, so after that there is the negative charge will take a proton from this source of, you have given already the water in the medium. So there is a Me, methyl. Now see, so this is the overall mechanism. Okay, now we have to do the second part of this question, that is polyphosphoric acid. So okay, you have to know the polyphosphoric acid, that is also called H3PO4, that is phosphoric acid also. So what it can do? It can do that in this type of compound, if H3PO4 or PPA, that is polyphosphoric acid, is given, then the ring closure is occur. Okay, ring closure is takes place. So if the ring closure is, how the ring closure will takes place? Okay, so here is your this type of double bond like here. Okay, I am writing this way. So there is a proton source H3PO4, so this oxygen will take up a proton and this OH plus, and after that the negative charge will attack over here. Okay, and these bonds will go like this, and after that there is a formation of this one. This is Me. Okay, now this, and here is your OH, and here is your OH. Now see, the double bond goes from this system, and the aromatic system loses its aromaticity. So after that it always tries to gain its aromaticity back here, and now these bond protons will go here. And now see, if after I am writing this next step, there is Me, this is Me, and here the two here is your two OH group, it is this one and this one. Now see, this diol, this is a geminal diol. So okay, so this type of geminal diol always tries to form a aldehyde or ketone. Okay, so there is a two alkyl group, it always tries to form a ketone. So after removal of one molecule of water, so this H and OH will remove from the system, and there is a leaving of water leaves from the system, and after that your product is this. Okay, so this is your final product. This is your final product. Okay, now to find your answer. Okay, see the positions, that is if I am numbering from here, this is 1, 2 and 3. The carbonyl group is 1 and this is 2 and 3. Now see, if I numbering here, this is not possible, so this is not your option. This is not your option. This is also in both are in same 1 and 2 position, so this is not your option. Here is your 1, 2 and 3, so this is your correct option. And in check, you can check option 4 also, this is not your option. Okay, so answer 3 is your correct option. Now I already mentioned that here is a regioselective process and stereoselective. Now for this question we have done the regioselective part, and there is also stereoselective. I am writing this here, and how the stereoselectivity occur during this reaction. Okay, now taking a substrate like this. This is Cl double bond here, and so OH, and it is protected by this group THP, that is tetrahydrofuran, so tetrahydropyran. This is the protection of the OH group, alcohol group, and in this case Na OMe in presence of methanol. This is your reagent, that is base. And after that, I already mentioned that 6-member ring, and in case of 6-member ring, they are turning to formation of 5-member ring. So if the 5-member ring is takes place, 5-member ring formation takes place, then what will be your product? Now see this group. Now after that, we already seen the previous mechanism, the formation of this group. Here OMe is in the previous in the question that water is acts as a nucleophile, but here is no water, there is a methanol by OMe which is acts as a nucleophile. Okay, so okay, this is this. Okay, these groups are as it is in same. And now see this from what is the mechanism of this reaction. Here is a negative charge, this will go here, and the Cl is removed from the system, and during this this negative charge is here, and after that the methanol will this 3-member cyclopropane ring will open via this nucleophilic attack of OMe. Now see, this Cl is in below side, as a back side, and here is a formation of CO2Me, which is your after reducing of this after this 6-member ring to formation of 6-member ring to 5-member ring, there is a formation of this CO2Me group is also in backside. So this is called stereoselectivity. Okay, so this is stereoselectivity. And another thing is that is I mentioned that there is a different type of Favorskii, that is quasi-Favorskii. That is quasi-Favorskii. So now what is this? Now this is a different type of not different type, it's all very same type, like only Favorskii type. Here and 5. Now see, there is a I already mentioned in the case of Favorskii reaction, that is there is a presence of acidic hydrogen. But if there is no acidic hydrogen, that like this is alkyl group, these two are alkyl groups, so no acidic hydrogen, and this is the leaving group X or kind of halides. And if you given a nucleophile like this, so there is a type of rearrangement, and you get this type of product. Okay, so this is quasi-Favorskii, and the question is also asked from this topic, and this question is also came in the question was came in CSIR-NET 2019 December 2019. So okay, so this is all about this concept and topic, and I hope this video is useful for you. And if you like this video, then please subscribe to my channel, and today for this so thank you for watching.